Good afternoon. And congratulations to Christian for having said it without stumbling. That's, yeah, very good. So, good afternoon. I'm JP, or JP Mens. Many of you know me. I'm a consultant. I do all sorts of things. Particularly, I do a lot with DNS. I've done quite a bit of things with Ansible, quite a bit of contributions to Ansible, and I do sort of little bits and things. And one of the little bits and things I've been doing over the last years, some of you may or may not know, is been working with a protocol which is called MQTT. Who, may I see hands, who has heard of MQTT? Okay, for the camera, I see approximately 50%. Who's actually worked with MQTT? Oh, quite a few. That's 32.7%. Very good. Can you tell me, please, all those who have worked with MQTT, why I show this bottle of ananas or pineapple liqueur? You have not worked with MQTT. Otherwise, you would know that. Now, it's not the pineapple, it's the brand. It's called 1883. And 1883 is the IANA allocated TCP port number for... there we go. Right, okay. So they also make chocolate sauce. Anyway, just a very short, I'm not going to tell you a lot about MQTT. I'm going to tell you about a lot of use cases for MQTT, which I think is the more important bit. You can read about the protocol other places. MQTT is a very lightweight protocol. It's a publish-subscribe standard. It is TCP-based, not UDP. It is TCP-based. It is designed for unreliable networks. Unreliable networks is, for example, what you have in your or most of you anyway, in your purses or in your pockets and the smartphones. It's horrendously unreliable. Here we have Wi-Fi, which is terribly unreliable. And then we go out and we have 4G, and then we have 3G, and then we have O2 or E+, which is in German that stands for offline. Okay, and then we come back. Then we come back to the Holiday Inn, and then we're completely offline. So that's for very unreliable networks. And we have quite a bit of experience with MQTT on mobile devices because we created a project called OwnTracks, which does location tracking. So I'll show you a screenshot in a moment. Location tracking based on MQTT for smartphones. So if you ever want to do something that's really hard, that is anything that has to do with mobile communication. Anyway, so MQTT is a publish-subscribe protocol. It's lightweight. It can carry binary payloads of, in theory, up to 256 megabyte. I say in theory because I have here, for example, a little ESP8266 microcontroller, which costs a fortune. They're very, very expensive. And it also does MQTT, and I'll prove that to you in a moment. Now, a little microcontroller that has a few kilobytes of RAM can, of course, not handle 256 megabytes of payload. So this is more of a theoretical amount based on large clients, on fat clients, okay? But not necessarily for thin or very small clients. MQTT does TLS, Transport Layer Security. None of you know what that is. You all call it by the wrong name, called SSL. It hasn't been called SSL for the last 20 years. It's called TLS, Transport Layer Security. Anyway, we do authentication. We can do payload, encryption, of course, in MQTT. All sorts of very nice things. And what else we have? We have something which is called a last will and testament. Last will and testament is what you and I, if we're sensible people, we fill one in just before we die. No, actually a long time before we die, because we don't know when we're going to die. And that is exactly the same thing in MQTT, and I'm going to show you that in a little moment. And MQTT clients speak to each other via a server, and the server is called a broker. This broker is nothing else. It's a very fancy name for a server, and this broker is here centralized in the center here, and we have clients around this broker. We have on the left here a few publishers. Publisher is something or an application or a program or a sensor or an actuator which actually creates messages, and these messages are transferred and transported to the broker. The broker then, under certain circumstances, transfers these to a waiting subscriber. If the subscriber is subscribed to a so-called topic, what that is, I'll tell you in a moment, to a so-called topic, which is the same topic to which a publisher is publishing. If the publisher publishes to a topic, and there is at least one subscriber to that topic, then a message is transferred via the broker. A publisher can also publish messages to a broker. If there are no subscribers listening, then those messages die. They just disappear, okay? Topics also, generally speaking, do not need to be pre-allocated or predefined. The fact that a publisher publishes to a particular topic means that topic is created and suddenly then available. What we can have are, of course, clients. Here at the bottom we have one, for example, which do publish and subscribe. So as an example for something like that, and I'll be showing you a practical example in a moment, as an example for something like that, assume you have maybe a small sensor which you bought in the United States. That's one of the 3 countries in the world that doesn't know anything about the metric system. Apropos, United States, any news? Anyway, that's a different topic. That temperature sensor would publish in something called Fahrenheit. Now, we don't understand Fahrenheit, so what we would probably want is to write a small client, just quite trivially done, just a few lines of, for example, Python or any of your preferred languages, write a small client which subscribes to that Fahrenheit temperature, converts it to Celsius, and republishes it, for example, under a different topic. Okay, so clients which subscribe and publish, which can subscribe and, for example, republish, are something that's quite frequently done. So these brokers in the center, those are our servers. There are a number of different kinds of broker. There's a broker called Mosquito, for example, written in the C language, written by a man called Roger Light. By the way, the English fly is spelled with 1 T. Roger was looking for a word that contains MQTT. That's why the mosquito is incorrectly spelled. A very popular broker, open source. It supports basically all features that MQTT has and some more, including TLS PSK, pre-shared keys, for example. So very popular, available in all decent repositories, so apt-get or whatever, yum install. Is it still called yum? Anyway. Right. Another broker which is extremely capable is written in Erlang. Erlang is this language that is, in German you say unkaputtbar. It doesn't go kaput. Yeah? In theory, anyway. VernMQ, very, very popular, also highly capable. It, contrary to Mosquito, for example, also allows clustering, which is very interesting for high-volume scenarios. Other than that, it also has a lot of features. And there are a number of other brokers. There's some written in Java, if you absolutely must. There's HiveMQ, for example, which is a commercial product. There's RabbitMQ, which is not per se an MQTT broker. It's an AMQP broker, but it has also an MQTT connector to it. So I spoke about topics. Topics are a hierarchical name or hierarchical names slash separated. A topic can be 64 kilobyte UTF-8 characters. That should be enough for most applications. The definition of a topic, or what a topic looks like, that is up to you. There's up to the application creator. Here are a number of examples. So we have, for example, apparently a kettle. I don't know why you would want a kettle that speaks MQTT, but if you do, then you might have a kettle that listens to or publishes to a topic called home, ground floor, kitchen / kettle. Then you might have some sort of financial system that publishes rates on the finance / currency / rate. The topics in blue here, those are typically topics, exclusively, topics that a subscriber would use. So, for example, finance / plus / rate that plus stands for a single topic branch, a single topic level, but a wildcard, but just one level. So we would find here finance yen rate or finance baht, the Thai baht rate, etc. Okay, and here at the bottom we have, for example, ontrack / JPM / hash. The hash is a little bit comparable to a Unix asterisk in file name globbing. That would stand for any amount of levels in any depth whatsoever. Okay. Topics can become, as I say, quite long, quite complicated. Here we have one, OpenHab / home OpenHab. You heard, who was here this morning with OpenHab? Okay, what I'm telling you, by the way, is one of the, well, maybe Mariana won't agree with me, but for me, it is one of the main controllers for OpenHab. So I do a lot with OpenHab and almost exclusively with MQTT. So openhab/homey/ then strange-looking serial number /$status/ uptime. So these topics can get very long and unwieldy. What brokers, and then I'll finish with the whole sort of server architecture. What brokers can typically also do, not necessarily, but typically also do, is bridging. We use this a lot, and when I say we, I mean, well, we, that's other people and I. I didn't want to go into details right now. We use this a lot in order to transfer data, for example, out of one data center into another. Now, when I say data, I don't necessarily mean a temperature sensor, because I don't really care what the temperature is outside of a data center. But when I say data, I mean all sorts of data. So, for example, we do monitoring. We do all sorts of things. We collect data in one data center, and we collect it and pump it into an MQTT broker. And we can bridge then out a topic, a number of topics, a whole bunch of topics out to a second broker, for example, either in a different data center or in a different location, for example, for backups. And the great advantage of this is we have then one outgoing, respectively incoming, depending on how we configure it, one outgoing and one incoming a TCP connection, which is optionally, of course, encrypted with TLS. So it's a wonderful way of getting a whole bunch of different data out of a center. And as I say, irrespective of sensors. Now, what I'm telling you here is a little bit about sensors, but also about all sorts of other things. The other things you'll have to imagine a bit, okay? Right. We have two main client utilities which are also provided by the Mosquitto project. That is Mosquitto Sub, which has about 5,792 options. Roger Light is currently working on another option called -y, which will allow MQTT version 5 parameters to be set. So we have Mosquitto Sub, -v is verbose, and you can specify host and port and whether you have TLS or certificates, etc. Just a few options here. And -t topic, here for example topic/hash or just a hash, whatever. And we have Mosquitto Pub, which is the publishing side, optionally with a retained message. If we have a bit of time, I'll tell you what it is. And otherwise, I'm sorry, there's a topic missing, -t topic, and -m would then be the payload. Language bindings for MQTT exist in, I think, all languages. The only one I haven't found that was COBOL, that didn't have one. But the good news is there is a COBOL bridge for Node.js, so your afternoon is your afternoon is safe. If you don't want to go to the party tonight, you know what to do, right? Okay, so practical solutions. Why MQTT? Why do people do MQTT? MQTT, by the way, is now almost 20 years old and has been used in the past and still continues being used for monitoring? Alerting, metering. So, for example, there are electricity metering products which come out of the box configurable with MQTT, more in the commercial area. There's even an espresso machine made by Italians which uses MQTT for pushing out statistics, how many cups of espresso were made, how many beans were used, etc., etc. I'm not kidding you, by the way. No? MQTT is used a lot for logging. MQTT is used for location awareness. One of the products that you have is own tracks. Here you have two screenshots. On the left is a screenshot of Android. On the right of a slightly different view in iOS. It's an open source MQTT-based application. We use MQTT for automation. Was saying OpenHab earlier, for controlling, for all sorts of things. So all sorts of things speak MQTT. You have simple devices and you have complicated devices, and of course in software we do a lot of MQTT. So for example, you have all sorts of Internet of toilets is the word, I think. No? Okay, so let's see a little bit of MQTT. I'm going to show you two things. Now I'm going to hand these over. This is live, okay? So don't kaput it, don't break it, yeah? Don't pull the plug. If you pull the plug, my demo dies, and I'd be very pissed off if you do that. So I'll hand this around. Now this is an OpenWRT little mini router. It's called a pocket router. They cost somewhere around, kind of around 22 euro, 24 euro or something. there's an, as I say, a Linux distribution in it, OpenWRT, and obviously there is a, what am I looking for? A broker on it. There's a Mosquito broker running on it, and this thing has a wireless access point, and this wireless access point is currently active, and my Mac and all the other toys that you see here are connected to this wireless access point. It might be that I'm going to ask you to bring it back quickly, because I don't know how far the what you call it, the range is without an antenna. Okay, so as I say, please don't pull the plug. Yeah. The first thing he did is pull the plug, or what? Okay. Okay, what I'm also going to hand over, but I want all the stuff back, okay? This all comes back here. Nobody leaves the room without it. Right. And what I'm also going to hand out here is a little ESP8266, which is a microcontroller. Who has heard of Arduino? Okay, for the camera, it's about 30%. Arduino is a product created by Italians, absolutely fantastic product, because it allowed people like myself, who had nothing to do with electronics, and also developed people, to suddenly sort of dive into the world of electronics and get blinking lights going and so on without really having a lot of know-how. Now, the Chinese improved a little bit on the Arduino, or let's say maybe not improved, but they modified the design a little bit. First of all, from cigarette package size to just stamp size. The actual ESP8266 is that single slice at the bottom. The thing on the top is just a button, okay? And this single slice at the bottom, the Arduino costs somewhere around, let's say, 25 to 35 euro, but has no connectivity. With added Wi-Fi or added Ethernet, costs even more. This has an onboard wireless access point and a wireless access client. So, of course, the price is going to be tremendously different. That's why I want it back. It's very, very valuable. It costs, including first-class registered mail shipping from China, about 350 cents. So, hang on. What I actually want you to do, and would you please click? Press the button. It won't bite. Stop. Stop. Once. Who said click twice? You broke it. Now it says 2 there. It said 1 there. Now hand it over. Thank you. Only once. Yeah? Now, if you press twice, from now on, if you press twice, it costs a gin tonic, okay? 3.
But you have to drink them all.
4. Yeah, of course I will. 4. Hand it over. Display's on 4. 6. That's 1 gin tonic. If you pay attention, it's modulo 5, okay? Right. So, and what you should be seeing is every time you press, I don't know whether you've noticed, every time you press, there's a topic being published here. So that thing is actually talking, that thing has an IP address, okay? We can ping it. That thing is connected to an MQTT broker. Where's the broker at the moment? Okay. So we're still in range. It's connected to an MQTT broker. Would somebody, whoever has it at the moment, would you please click, 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 click? There it is, okay? There go the true false. Every time you press, the button is open false, and when you let go again, it's open true, okay? That's the logic behind it. Okay, now while you're pressing and so on, I will continue. So carry on. Don't pull any plugs. Okay. So while you're present, we will continue. So we do all sorts of things with MQTT. And one of the first things that we started doing was all of us, anybody who did anything with MQTT, we started writing programs. So we started writing, I don't know, my toilet flush to MQTT and MQTT to Twitter and MQTT to IRC and so on and so forth. And this got out of hand. And after what feels like about 1,517 of these programs, most of which still exist somewhere, I said, no, this can't be it. We must be able to do this better. And what we did was to then create something called mqttwarn. The name is a bit strange, but all the good names were taken, like Asinga, and they're all taken. So what mqttwarn is a system which is written in Python. It's an open source project, of course. It's written in Python. And what it basically does is subscribe to any number of topics that you want. Okay, so it connects to an MQTT broker, subscribes to any number of topics that you want, and will then take a payload that is produced by a subscription to one of these topics and then distributed to a service. So for example, we could have something like home/alerts, that is the topic. No? We could have that, for example, distributed to XBMC, which is now called Kodi, I think. No? Is that, yeah, Kodi. Or we could have it taken to pushover, or we could, for example, have topics that are published to monitoring/whatever, so your Isinga, your Nagios, whatever they're all called. I beg your pardon. They would publish to monitoring/something, and that would go to Twitter, and it would go to SMTP. So we have a whole bunch of what we call services or plugins that you can plug into MQTT warn. And I'll show you a list in a moment. And these will then cause the payload, sometimes transformed or naked, or however you like, to be distributed to the appropriate service. So in theory, what we can have is, for example, your house bell, your doorbell, which would, if you press it, would create a publish with maybe the word ding on it. You could have that suddenly pop up a pop-up here with doorbell, ding dong, and a little logo while you're watching your movie in the evening. So what does MQTT warn today do? We have over 60 plugins. I think there's 64 at the moment. All sorts of different plugins. We can do Redis publish, and we can transport to Zabbix and XMPP, and we do Carbon and Linux iNotify and Log and Mattermost, and I think Slack is also there. All sorts of different plugins. We can do WebSockets, post to Twitter, etc., etc., etc. Now the use is relatively simple. I'm not going to bore you with a lot of details here. We have a configuration file which contains a number of defaults, and then we launch you launch the services that you want. So here, for example, I'm just launching the file service, and each service has a configuration. Here we have a file service which I'm calling record, and we can have a whole number of different file services, and you can have a whole number of different Isinga services and Twitter services, etc., for example, for different accounts. I'm calling record, and this will go into a file called /temp/couscous. And what we do here is we configure a subscription topic hello/plus. We know already plus stands for one level, wildcard. So any message that will be published to the topic hello/ABC will be picked up by MQTT warn and will go to target file::record. File::record is this file target with the sub-element record. In other words, whatever we publish will go into the file /temp/couscous. Let's see if that works. Mosquito publish minus topic hello/A minus M is the message or the payload. And I'm sending here a JSON blob, a JSON object, and if I look at /temp/couscous, it contains exactly what was transferred. We didn't modify it in any way, okay? So that's as sort of boring as it can get. And what we then, of course, can do is we automatically decode JSON. So for example, if this is exactly the same configuration we had earlier, we say here, though, the output format should be welcome, comma, dear, and then the element name. And what happens is MQTT warn automatically attempts to decode incoming messages, decode into payload, and then, of course, gives us the elements. We publish exactly the same thing, however, to a different topic. The topic doesn't matter. Look at the last line of /temp/couscous, and here we see the message, welcome, dear Jane, contrary to what we saw earlier, and there was the actual JSON object. Okay? So, with a few lines of code, we can then add, for example, a target of type XBMC, which will ensure that our doorbell is then transferred to the bedroom component of XBMC. And the bedroom component of XBMC is the XBMC or Kodi player at that address with that password and that username. Okay? One of you then might say, well, I'm maybe not watching TV when the doorbell is pressed. How about, can we have that over SMTP? So can I get an alert via mail? The example with the doorbell is, of course, idiotic, but I'm just trying to prove a point. And that is, yeah, sure, of course we can. We add a configuration for a local SMTP server with username, sender, blah, 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 subject, etc. And we add to this thing, we add a target. So we went earlier from, let me go back a second, to XBMC bedroom. That was our target. And now, go forward again. We add XBMC bedroom, comma, SMTP and local JP. That's my target here. Same configuration otherwise, and the result is then an email whenever the doorbell goes. Okay, you, I'm sure, get the point. So what we can use this for is also for. I'm sorry. We're in Nuremberg, right?
Yes.
That's the wrong slide deck. Let me fix that. Right. So we can also use this for monitoring. We can also use this for monitoring, and what I'm going to show you is a small example using Zabbix as a monitoring system and MQTT. So what we're doing, I'm going to skip over this very quickly because my time's running short. I can talk to you about this for hours and hours and hours. My time's running a bit short. I have in Zabbix, I have configured an item. This item has a trigger connected to it and will alert us whenever the temperature is greater than 25 degrees Celsius. When that happens, what is going to happen is a script is launched in a so-called Zabbix media type, and this script is going to just start a shell script, which I'll show you in a second, and we'll just send over a subject name containing a bit of JSON on it. You can look at this a little bit more in detail later on. And what we then do is to actually invoke this shell script. What the shell script actually does is just a user bin mosquito pub, connects to a broker on a particular port. Here's an example where we want to ensure that we're protecting our payloads here with a PSK, in other words, with a TLS PSK, with a pre-shared key. What we could also do is configure with TLS certificates, etc. Here with a pre-shared key. We send to a particular topic and the payload as the appropriate message. And in or within mqttwarn, I have the following configuration, which looks, you've seen this already, at least very similar. We have a Zabbix configuration with a so-called trapper address. So we have a trapper configuration. That is, trapper is in Zabbix an endpoint onto which, you probably know this much better than I do, but anyway, in Zabbix, a trapper is an endpoint onto which I can publish, I can write data. And we have in MQTT1, we have, of course, a Zabbix plugin which allows us this. And what we have also here is a small Python function. This Python function is loaded in, sorry, let me show you back here. In MQTT1, we have Python functions which get the data, can transform it in any way you want, can do whatever you want with this data, and pass it on. So what we're going to have here now is, where's my broker? It's here. No, that's a button. That's a broker somewhere back. Okay. This is what we're going to be doing. Okay. So we have our MQTT broker running on this little thing here. We have a temperature monitor. I'll show you in a moment what it does. We have a temperature. No, I'll tell you now what it does, but I'll show you what it does. A temperature monitor, and this temperature monitor is going to do following. It's going to verify the published temperature, and it will alert us by flashing light or by switching on an alarm light when the temperature rises above, I've forgotten, I think above 20 degrees Celsius. Then you have the button that you've been playing around with already, okay? And we have here our Zabbix monitoring on the right, and here on the top we have a 7-segment display, which you've also been playing with. And let me get rid of the slides. Here on the top you see the information that's being published. So you see everything that is being published onto the broker, onto the little blue broker that went around. So for example, you see that switch has been publishing an uptime. It's been up for 2,486 seconds and it has a Wi-Fi signal currently of 88, respectively 92, and so on. Okay, so that is being published by the is that 10 minutes or 15 minutes? 15, thank you. And on the bottom left, we have our temperature monitor. Okay, and in the background here we have we have Zabbix. Now, the difficulty with monitor or with doing things with temperature is the reproducibility. So what I have here is another ESP8266 with same thing as the little blue one that you had around, with a potentiometer on it. And with this potentiometer, I'm going to be manipulating the temperature. If all goes right, it does. The temperature that it currently has is being displayed on the LED, okay? So this thing is also publishing via MQTT. You can see it. You can't. You should be able to see it. Let's try that. Not perfect, but anyway. You should be able to see it on the 7-segment display, and you'll be able to see it down here. So the temperature here is being published, okay? It's now on 13, and this temperature you also see at the bottom here. This here is the temperature monitor, okay? This temperature monitor is just monitoring to see whether the temperature, I'm twirling it up and down, no? It's just monitoring to see whether the temperature rises above 20 degrees Celsius. So this thing at the bottom is actually a subscriber, but it is also a publisher. You also see that our temperature is now being graphed by Zabbix, okay? Nothing particularly special there. And what I'm now going to do is to bring the temperature above 20. Now, when I bring this above 20, we'll see the temperature monitor, come on, there. The temperature monitor detects it's above 20, displays there a true, just to show you on the screen, because I don't know whether you can see this, and this little red LED went on. How did this little red LED go on? If you notice this line here, fourth from the bottom, there's a mosquito publish, there's an MQTT publish onto a topic called red LED on set with the command true, and the device returns back and says, thank you, I have switched it now on, I've now switched it on, and the status is now true, okay? So the LED is on, let's increase the temperature, and what we're going to do is we're going to go above 30, and then we immediately get sent by mqttwarn, Zabbix/alert, type problem, and you see at the top, Zabbix is now complaining, the trigger has fired, the temperature is now above whatever it is, 30 degrees or 31 degrees, okay? Right, and we can bring this back down again, and of course everything will quiet down. After a while, the red light has gone off, and Zabbix has now published a payload type resolution. Value is now 19, so in other words, everything's okay. The false alarm we can do away with. The monitor has returned to normal, or the sensor has returned to normal. Everything's fine. Okay, so that is what's been happening here. And here's a screenshot of what we saw there. Now, what I would have liked to show you live, and I can't because of the environmental situation, that's a euphemism for shitty Wi-Fi, is that by adding just a statement or two to our mqttwarn initialization file, to our mqttwarn.ini, I configure pushover, and then I can transfer this exact same alert to a completely different service. For example, pushover. Pushover is a very nice little service, and this is what the result looks like on my phone. You can look at it later on if you like. Here it says temperature is at 28 Celsius, OSMC 2018, that's the title that we have here, and thereby, by just adding something to mqttwarn to the init file, and without touching the source application, that's the important bit, without touching the source application, we suddenly fan out to different services. One last thing, and that is LWT, Last Will and Testament. Last Will and Testament is a feature by which a client can indicate to an MQTT broker that in the case of its demise, in the case it dies, then the broker should, on behalf of that dead client, publish out a value, okay? The client which is connecting will indicate what the value is, which should be published, and will also indicate on which topic it should be published. So in other words, this temperature monitor that's been running, when it started, here's a bit of Python code, when it started, it indicated that on the topic MQTT/client/temp monitor, with a will set, last will and testament set, the payload string 0 should be published. In other words, the client then connected to the broker, that's the broker, the little blue broker, connected to the broker and started doing things and listening and publishing, whatever. And there will come the moment when this client then dies. And when this client dies, the broker will then, on behalf of the dead client, publish this information. So we see at the moment currently the Zabbix status at the top resolved. So the problem with the temperature was resolved. And what I'm now going to do is to abort this client. Control-C is an abort, okay? I could kill it off. I could, if it were a piece of hardware, I could pull the plug. I'm now going to just abort this client. And when I do that, then we see a second later, temp monitor client is dead. That is a publish that was produced by the broker, by the MQTT broker, because the MQTT broker realized that the client had disappeared, gone away, was no longer reachable network-wise, and then published this information on behalf of the broker. You said I had 10 minutes, but now I have 10 minutes.
Yeah, but questions.
Oh, but you don't have any questions. I've explained everything so well.
So you have 10 minutes without questions or around 5 minutes with questions?
That's far too complicated for me. Okay, right. So basically what I would like you very much to take away is MQTT, a very, very lightweight, simple protocol. Much more lightweight, for example, than HTTP, which is quite expensive. If you think of all the headers that HTTP carries along with it, content type and content size, etc., the hosts and blah, blah, blah. Very, very lightweight. With MQTT, we can construct systems where we literally decouple the producer of a message from the consumer of a message, and that makes it very interesting, at least very interesting for certain applications. In other words, what sort of in our speak, in our monitoring speak, we would, with MQTT and with something like mqttwarn or custom-made clients, which are also very simple to build, we substitute SMTP by, basically whatever kind of service you want and whatever combination of services you want. And that's what makes it actually quite interesting. So mqttwarn is, as I say, an open source project, which we created, I think the idea was mine, but my friend Ben Jones and Andreas Mottel have taken over. They're doing a lot with it. Andreas is now bringing mqttwarn into a PyPy installable state. We already have a first version, and you're welcome to experiment and have a look at it. That's it. Thank you. I believe I now have you have now 6.5 minutes for questions, if I've been counting along, bro.
8 minutes.
8 minutes.
Yeah, you speed it quite up. So, do we have some questions?
Loud and clearly, please. I'm deaf. Well, hard of hearing. What?
Okay.
And nobody leaves the room without that router. Where's that router? Ah, there it is. Okay, fine. Right, carry on.
Can I also configure like the opposing thing of a last will testament, for example, to undo my last will testament if the client becomes alive again?
Yes, of course you can. I didn't tell you that because that costs extra. The opposing thing is not really an opposing thing. What we have is, I mentioned it shortly with one letter, -R, with a mosquito pub. This is a retained message. What we can do in MQTT is to have so-called retained messages. And with retained messages, a client publishes a message and indicates to the broker, please retain the last value. And it's really only the last value that is retained. And that means that when a new client comes up and subscribes to that same topic, the broker will immediately give it that last retained value. So for example, typical use case, temperature sensor. Yeah, you have a temperature sensor or something similar which publishes temperature every 10 minutes. Now, if your client comes up at minute 01, it will have to normally wait another 9 minutes for the next temperature to come up. Now, in this particular case, with this particular application, it doesn't matter. You can give it the old temperature that was at minute 00, and that would be a retained message. So I have not yet answered your question, but I now will. What we do with this retained message is to do exactly this. So when my client comes up, when my temp monitor sensor comes up, what it'll do is publish a retained message saying, I am there, status 1, I am online. Yeah? And it will then set the last will and testament to, when it dies, tell the broker to publish a retained 0, instructing or telling all the clients that it's now offline. And so we can do that via the retained messages. Yeah.
Thank you. Any more questions?
Earlier you talked about hardware already being able to speak MQTT.
Yes.
What kind of hardware were you?
These are electricity meters created by I was hoping you wouldn't ask, created by a Swedish company driven by Carl, can't remember his surname, who's very active in the MQTT area. And the company is called something electric. I'm sorry, I'll have to look it up for you.
General Electric? No.
Say again?
General Electric?
No, not so general. No, it's a Swedish
Maybe
company.
not yet.
It's a Swedish company.
Maybe you are talking about IKEA.
And the IKEA thread-free lamps, for example, they don't speak MQTT. They speak CoAP. CoAP is if you like, HTTP over UDP. It's something completely different. Okay, so unfortunately, they do not speak MQTT. But CoAP is standardized. It's an RFC, a request for comment, so it's standardized. MQTT is also a standard. It's not an RFC, but it's an OASIS standard. Any further questions?
Anyone else?
Yeah. Just a short one. Can we see the execution line of your two bash consoles? If you show them to us?
Oh, that's highly secret.
Yeah?
Yes.
I guess so, yeah.
Do you have a support contract?
Not yet.
That's a good one. Yes, certainly. You just want to see the script, what it does? Yeah, sure.
What do you execute? I mean, the upper one.
It's just mosquito subscribe. So what I'm doing here is I create in Tmux a double session, so you can see it both at the same time. And the top part was just a mosquito sub, which I'll do in a moment. And the bottom part is temp monitor.python. There's a small Python script. So what we're actually doing, am I mistyping? Mosquito_sub minus host 192.168.8.1 minus verbose, so I see the topic name minus topic hash. Any mistakes in there? No, looks okay. So we have here, look, for example, the last will and test, this parameter, MQTT clients, temp monitor 0, that is, Peter Hollands isn't listening anymore, unfortunately, but this is a retained message, okay? Just like this is a retained message. That last device was online, okay? So this is just the mosquito sub. We're just subscribing to all messages. I will now publish a message myself, mosquito, you can't see it, pub minus host 192.168. 160, thank goodness, not IPv6, .8.1 minus T OSMC talk at 1430 minus V M. I did it. Okay, so anything that is being published to this broker, I can see. Now, the reason I can see it is, I'm forestalling the next question. The reason I can see it is because in this particular case, the broker has no access control list configured, so anybody who can physically connect to the broker can actually publish something on any topic, and anybody can also subscribe. That is something that we typically don't do, so we are very careful with access control lists so that you can only see what you're allowed, what you're permitted to see, obviously. No?
So we have time for one more question.
One more question. No more question.
Okay.
Thank you very much.
Thank you very much.